Okay, well, so far we've gone through and changed the amplitude of the sine and cosine functions. What do we do with this period? So let's talk about that. Generally speaking, the way that we're going to treat this is that anytime that we have an expression where we're taking a sine or cosine and there's some number multiplied by the cosine or by the value of x before we take the sine or cosine, that is going to be a change in the period of the function. And the way that we treat it is that we say the new period of the function, will be equal to 2 pi divided by b. So a word about these key points right here. Normally speaking, when we say our key points are 0, pi over 2 pi, 3 pi over 2 pi, this is for the basic sine or cosine function. So these are key points when it comes to the expression y equals sine of x and y equals cosine of x. Since we're dealing with a sine function, we'll say that these are the key points for y equals sine of x. So what changes when we say something like this, y equals the sine of 2x? Well, here's what you're going to do. If you get a new function and we want to say y equals sine of 2x, what is the period? We're going to change the period of the function. We're going to say, well, one full cycle then will be equal to 2 pi, in this case, divided by the value being multiplied by x, so divided by 2. And so one full period will be completed within pi units rather than 2 pi units. So if you're thinking about adjusting your period, right, our new period is going to be adjusted as follows. For our function, the period will be completed starting at 0 and ending at pi. So what we're going to do is we're going to divide up the period into 4 key points, or 5 key points starting at 0. Not really. Those are key points. I don't know why my pen doesn't like cooperating with me some days, but you know they don't. So 5 key, that's a K, 5 key points that we have to deal with all the time are going to be 1/4 times the period, 1/4 times the period apart, 1/4 times pi, or pi over 4 apart. What we do, if we want to get the key points for our new function, is take 1/4 times the period apart from one another. Right, so 1/4 times the period, that's what this says. 1/4 times the period apart. Okay, so in our case, we're saying our key points are 1/4 of the period apart, pi over 4 apart from each other. So we would start by adding 0, add pi over 4. That's our first key point. Take pi over 4, add pi over 4 again. We get pi over 2. Notice that the difference between these two is pi over 4. Take pi over 2, add pi over 4 again. We're at 3 pi over 4. If we add pi over 4 again, we're at 4 pi over 4. Well, that's just pi. So our new function will have these as the x values for our key points. Okay, so this is the values that we would use to graph our function. So I'm going to go ahead, I'll go and let's graph our function this time. We've changed the period, but our amplitude is still equal to 1 here. So let me get my pen right here. Our amplitude is 1. That part hasn't changed. This time our period has gone to pi. Our domain will still be all real numbers, and our range will be just like the original function from -1 to +1. So how do we work this out? Let's go to our points along our key points on our axis right here. Before, we had said one full period would be completed within 2 pi units. Now they're going to be completed within pi units apart from each other. Here's pi over 2. Let's divide this up a little bit further. Our key points are at 0 pi over 4, pi over 2, and 3 pi over 4, and then finally one full period ends at pi. So what's going to happen right here is our y value goes up as high as 1, goes down as low as -1, but we follow this pattern that's over here. Remember, we haven't adjusted these y values by changing the amplitude. So we're going to start our graph at the point 0, 0. At pi over 4, we're going to go to 1 this time. At pi over 2, we're going to go back down to 0 this time. At 3 pi over 4, we're going to go down to -1. And then at pi, we're going to come back to 0. And then we would repeat this same pattern over again. All right. So one cycle of the function, one period for our function, looks suspiciously like this. And if we just repeat this pattern over again, we see the same pattern just repeating itself over and over again every pi units. Right? So right here, this is a picture of 2 full cycles of it, but you can see that we have one full period right here from 0 to pi. All right, so in this case, that's what it looks like. Now, if for comparison's sake, if we look at our cosine function, our sine function, just in the basic reference graph, we would have gone like this: 0, 1, 0, -1, 0. So a good way of thinking about this here, I like putting this graph just for comparison's sake so you can see it. This is the graph of y equals sine of x. If we compare the original graph to this graph, you can see what's happening right here. It's as though we're compressing the number of cycles by 2. In other words, we're getting 2 cycles for the price of 1. So another way of thinking about this formula for the period is that we have 2 periods completed in 2 pi units. Okay? So a good way to think about this right here is that if you want to use this period formula, 2 pi over b, the value of b tells us how many cycles we'll get within 2 pi to get a full period, right? So for our full period right here, we get 2 pi over b, we get 2 full periods right here. Okay, another example like this coming up in the next video.